So as Craig mentioned, I'm going to discuss improving speed and reliability for service operations. And first thing I would like to do is just distinguish service operations from project environments and from manufacturing or production environments. So let's see if I can. Okay. So project environments, most of us are very familiar with projects. So some distinguishing factors for projects is that the touch time is significant compared to the overall cycle time. And projects in most organizations are done in what I would call a smaller volume, somewhere in tens to maybe 100 and more. And there is a low repeatability of work content. So what do I mean by repeatability? I mean that for every project, the scope and deliverables are distinct. So what that means is that we can't build an inventory of projects and we can't swap them. They're not interchangeable. So that is some distinguishing factors of projects. For production, the touch time is very small. So here the work is shown with a W. The amount of work to the overall cycle time is small. And what that means is if the order takes 1 to 2 days to process, that we would quote that order for, say, 22 days. And this is typically scaled to high volume, more in the range of 1,000 and more. And, here we are, production. Scaled to the range of thousands and more, and there's a high repeatability. So what that means is for every order, we can actually build an inventory to meet that every order that we have. If we have a quality problem, we can scrap that part and we can fulfill our customer demand with the same work element processed through. So there's a high repeatability. Now for service operations, the distinction here is that there is also a very small touch time and there's a high volume, but the distinction really is that this cannot be automated fully. So you can't build an inventory of services. There's a low repeatability factor, and the work itself has a high variation. So let's take an example of insurance claims. So auto insurance. There is a lot of auto insurance claims. There's definitely a high volume. But the work content to process those insurance claims is different. So every accident's slightly different situation, and whether or not the person will settle or there'll be litigation or all of these things, they are not known up front. Again, the distinction is that this cannot be automated fully. We don't know the work scope, so it's not like a production line where we can automate those processes and build an inventory to meet our demand. So another example would be purchase requests. If you know upfront what you're ordering, if you know the technical specs, if you know who you're ordering from, and you know the price, there's no commercial considerations, that can be automated. But if there are gaps in your understanding upfront, you do not know exactly what you're ordering or where you're going to be getting it from, there's no supplier available, that cannot be automated. So we'll talk about a specific case study in regards to purchase requests. But before we get there, just to try to make the category of operations clear, some other examples would be software bug fixes. We don't know exactly what we're going to need to fix with the software that we've put out. And there's typically a high volume of bug fixes. Although we would like there not to be, there is. And it's small touch time, things we can turn around fairly quickly. Engineering tickets, the same thing, and even MRO back shops. We don't know the work scope that we're going to have before we route the parts and take a look at what actually we have to fix. So these are also examples of service operations. So first, the Defense Logistics Agency is a very large government organization. They manage the procurement and distribution of all material and supplies for the nation's military and several civilian agencies. So there's 23,000 civilian and military employees. fairly big, and they supply $42 billion worth of goods and services annually. Now, where we're going to dig in for this case study specifically is with the Defense Supply Center Richmond. And they are a part of DLA, and they are the primary source of supply for 1.3 million components and materials. I know there are some aviation-related depots in the audience, so I'm sure you're familiar. They supply $3.4 billion in goods and services annually, and they handle about 5.3 million requisitions, and that is for 24,000 roughly customers per year. So when we're talking about automation, they do 5.3 million requisitions. Some of those, most of those, can be automated. We know what we need, we know who we're getting it from, we know the price. But a significant portion of them cannot be automated, and that's where the service operations piece comes in for DSCR. So specifically for DSCR supplier operations, there's 1,200 employees. They have 14 procurement divisions that are distinct by the material that they support. And there's shared groups for technical and commercial assistance. So very simply, we could say that the material demand comes directly from the customers, depot, like helicopter depots or the case study we just heard. And it comes from DLA as a whole. We need to have certain material to fill the supply system. Once that material demand comes in, then it's DSCR's job to take that material demand, process it, and turn it into a commitment from a vendor that they will deliver. So that's what the purchase request block represents, and the purchase order also. And now the vendors may directly deliver that to the customers, or it may go into the DLA supply system. The point I want to make here is that DSCR does not own the supply system, the distribution network, but DSCR does own this process of turning material demand into something that their customers can get their hands on. So a purchase request, just briefly, we need to validate the technical needs or the quantities. We need to select a supplier or find a supplier, especially when we're talking about ordering some specific part that may be small volume. We have to go convince someone to make 10 of something. We have to set the terms and conditions, commercial and technical, and set delivery dates. So the three blocks on the slide here are pre-work to answer some of those questions, upfront solicitation to go and get suppliers, and evaluation to make sure that the commercial conditions can be met. And that's what the product of DSCR is in a simplest form or service. So what is the need and what results were achieved? So DSCR, the need, of course, primary need is to support the warfighter, so to get the parts and materials that are necessary for those people who operate these aircraft to do their job. And in order to do that, support the warfighter need, DSCR needs to increase the availability of material overall in the system, to have parts available when needed. Unfortunately, DSCR has a fixed budget. If they did not, then increasing the availability would be considerably easier. We would go buy a ton of everything, and there would always be something to pull from the shelf. But they have an additional constraint which says they have a fixed budget. So the question is, what can DSCR do to meet their business goals? It's, again, simple. They can buy the right parts at the right time, but there's a but. But the demand is not known in advance. So we've listened to some depot maintenance case studies. So if we knew what the depot was going to need for the aircraft that they're going to process for the whole year, we knew up front exactly what material was going to be necessary once they tear the planes apart and look at what needs to be fixed. If we knew that, then buying the right parts at the right time would be a much easier thing. But I don't think the depots can tell DSCR that, so there's a challenge. And the demand uncertainty is here to stay. We won't find a way to know what we're going to need on the aircraft, how many hard landings or abandoned planes in the air we're going to have in a year. So that's not going away. So the question still is, what does DSCR need to do? We know they need to achieve a higher availability. We need to support the warfighter need. We need parts available. On the other hand, what they can also do or need to do is to have more budget flexibility. So how can they achieve that? They can order small amounts more frequently. So what we're saying is that instead of ordering for 6 months, and let's say spending $600 for 6 months, and hoping that $600 gets used well, they can spend $300 to cover a span of 3 months, and they can, first off, just invest less of their money at a time, which gives them more budget flexibility to get the right parts ordered at the right time. And if they're ordering over a period of 3 months as opposed to 6, they have more time to find out what actually is needed as opposed to forecasting. Now, the way they spend their money is on orders that we know are directly needed and on something above that. Right? We don't just order for exactly the amount that the customers say they need. We know there's this uncertainty, so we also order a buffer of material. Now, if they can decrease the amount that they have to hold in stock buffers and still maintain the same availability, then they can have more budget flexibility to respond when demand spikes happen. They'll have that money to spend. So the way to do that is to increase the speed of supply. If I'm more responsive to get the material to where it needs to go, then I don't have to hold as much buffer to protect myself. So if you can take the extreme example, if you could just in an instant go grab the part that you need, then you wouldn't have to buffer extra. You wouldn't have to keep any extra over what you actually think you need now. Okay, the other connection to stock buffers, if we are more reliable with supply, if the customer says, I need something, and we're able to give it to them in a reliable fashion, then we can also decrease the amount we have to hold, the stock buffers, to protect ourselves from demand uncertainty. And for those things that are urgent needs that have a direct, maybe things that aren't stocked, but we know we need them right now, if we can increase our reliability, then that has a direct impact on availability. The overall time that it takes to lead time for the material is comprised of the award lead time, the production lead time, and some transport time. So again, DSCR's job is to turn a purchase request into a purchase order, and then it's the vendor's job to supply. So what DSCR has control over, for the most part, is that award lead time. How long does it take us to process that purchase request? And the date that we're looking to meet in order to be reliable is the required award date. So to come back to our objectives, if we can increase our awards, if we can increase the amount of purchase requests we can turn into purchased orders in any given period, then we give ourselves the ability to order small amounts more frequently. If we can decrease the award lead time, that has an impact on the overall speed of supply. Their performance as of March 2009, there's a picture here that just shows, on the right you see how many days past the due date are PRs in their system, and on the left you see PRs that are haven't hit the due date yet. So all of the things to the right are late. So you can see there's a significant amount of things on the right. And there were also very high queues, high volume of work on everybody's desks. And we can also see that some analysis was done, and 75% of the PRs, if they were to meet that due date, would need to be done faster. So the objectives were to decrease the unreliability or the lateness by 30%, to reduce the lead time to award by 30% also, and increase the awards by 20%. So here we have results from August 2009. We can see a 40% decrease in the amount of days late to RAD, that unreliability, lateness reduced by 40%. A 76% decrease in the PR cycle time, so from the time that it takes to start the PR to process it into a purchase order, was taking 76% less time by August 2009, and a 29% increase in the number of PRs awarded over the baseline. So that amounts to about 1.5 months of additional throughput for the organization. Another story to mention for the results themselves is you may notice a point in the graph where the slope starts to increase. At that point, this is the throughput number of awards. Around halfway through, or a little bit past, you can see that there is a distinct rise in the slope. This is where all of the separate divisions, the 14 different divisions that they have, were online with applying the 3 rules. And you can see there that the throughput had a noticeable increase at that point. First, what were their challenges? These should also sound very familiar to everyone in a project organization. Resources are not available to respond to the PR demand. There's a competition for shared resources. Managers are pulled in many different directions. There's firefighting. Again, these should sound familiar. Huge crushing workload, large volume of PRs on hand. So it's one thing to have 15 projects going on, but when every person has 1,000 things on their plate, you get a word like crushing. Flooded by expedite lists, everything's an emergency. Internal coordination is difficult. And also the tech data, the questions that we need to answer are not always available to get a timely quote is the example. So, again, to come back to the flow, upfront, pre-work, and then solicitation. In solicitation, this is where DSCR is waiting on the vendors to supply them quotes. And this is typically a fixed period, at least a fixed minimum period of 15 to 30 days that DSCR is waiting to hear back on a quote. But the pre-work and evaluation periods for the purchase requests are done completely in-house, and they involve many groups. Many groups, I mentioned. Also, I know this is very hard to see, but this is the value stream map of a purchase request. So there's many different decision points in this process, and these decision points are not known up front. We don't know the answers to the questions at each one of these decision points until we get that PR, have it reviewed by someone, and pass it forward. So many different groups and many different decision points in the process of awarding a PR. So we have uncertainty in the work. We said that there's questions that we don't know the answer to when we get the PR, and we don't know them until we see them, and we see delays happening. The response, as we know, is the same, so this is the same as projects. If I don't start immediately on this purchase request, I'll never get it out on time, and that applies to all purchase requests. So there's a high pressure to start as soon as possible. This drives more work in process, and particularly what we see here are those huge crushing workloads that was described by the DSCR team. We see queues. We see every individual whose job it is to process a purchase request has a stack far beyond what they would ever expect to actually get through in a day, a week, or maybe even a month. So high queues, and that, of course, we know leads to delays. So again, what that looks like in this environment is a list, and my list is very long. I can maybe get through the first part of it on day 1. I can maybe get through the second half of it on day 2, but I never see the bottom of that list. I'm constantly working this ever-growing list. So PRs wait on capacity to move to the next step. It may just be a matter of someone grabbing it and taking a 1-minute action, 3-minute action to move it along in the process, an approval, for example, or a signature. But I have my list much longer than I can manage. So another response is to manage the local targets. So I said there are many groups involved in these decision points, and we want to hold each one of them accountable for processing the work, so we give them their own local targets. And of course, this leads to desynchronization, and what I mean there is that the groups are not having the same priority. So ultimately, we get out less. Our output is less than we really have capacity for because groups are not working on the same priority. So in their environment, there's the buyer or the acquisition specialist. There's managers that are needed for approvals. There's technical assistants we mentioned, people who work the supply system, cost and pricing, making sure that the costs are in line with the guidelines that are set, and reviewing of the contract. So all of these different groups have their different set of priorities, and so PRs, again, weight on the capacity for decision-making or issue resolution. Building lists and trying to justify the urgency of one work element, one piece of material over another. So constant and excessive expediting. And this, of course, leads to multitasking. If I'm working a long list and my boss keeps coming to me day after day and having me jump around the list based on that whatever fire is hot today, then that's going to cause multitasking. And then, of course, that leads into desynchronization and queues. It compounds that issue if our people are bouncing around from one work element to another. So this was their problem. And the 3 rules are the same as we've heard in the last few days. Limit the whip and control the release, remove the local targets, and provide uniform buffer priorities so that different groups don't have different priorities. So what limiting the whip and controlling the release means for DSCR is that the material demand comes in, of course, and we have a stack of PRs, and they're prioritized. Now, what was being done before is that as the system generated a purchase request, it would go directly to the buyers or the acquisition specialists based on some planned load. So they would have some material assigned to them, just like the divisions have material assigned to them, and the system would spit out the work in that way. So in order to control the whip, we needed to put in a release control point, so the work comes in, it's in queue. And a production controller is a new role in the organization to manage the release of these work elements. Again, we're talking about hundreds and thousands of PRs, but still, regardless of that volume, we needed to make sure that overall we weren't overwhelming our people and putting too much on our people's desks at a time, so that they could actually see the bottom of that list that they were working, and they could expect to get through that list in a reasonable time frame, like a week, and make sure that every item was touched. Okay, sorry. So this is release control in their environment. A big stack of work comes in, and a person makes a decision, production controller makes a decision as to how to divvy this work out. So that was a change from having the system push the work entirely to the workforce. Removing local targets we mentioned. So what targets did we remove? First, we had to remove the local lead time targets. So what this would look like was every group that's involved in processing a purchase request would think about their performance in terms of how long has it taken for me to process it once it's come to me. This has just come to me yesterday, so it's fine. Or this thing has been in my group for 30 days. So now all of a sudden, I need to move that item because it's been here too long. So that change, from that, we changed to putting only the fixed time, only what was actually necessary to process the PR, and having a shared buffer for all, so that the urgency wasn't driven on by the individual group's time that it's been processed in their area, but it's driven on how long the PR has been in process and whether we're consuming buffer. Also, we removed output targets for individuals. So again, another attempt to gain accountability for getting our work done was to put individuals on a schedule of a certain number of PRs per month that would say whether they were a good or bad performer. So people's responses to that output target was to choose whatever they could get awarded or touch whatever they can that would get them their output target, but it wouldn't mean that they were working in the order of priority for what was needed for the customer or needed for the supply system. The priority system was simple. If there's less than 10 days to the required award date, then that PR was red. If there's 10 to 20 days until the required award date, it would be yellow, and a green zone for greater than 20 days until red. And this priority system was the same across all of the groups in the organization. So if you can imagine the change, when you have this much volume, the amount of different priority schemes is even higher than maybe what you've experienced in projects, many different categories of whether something is urgent or not, and we went from that to red, yellow, green based on the buffer. Also, we needed to allow limited expediting. We needed to put in place a fast track process for work elements so that we could respond to urgent customer needs regardless of the planned date that the system says that we need to award that, or regardless of that item's place in the queue. We need to allow a fast track process to make sure that the customer needs were being met. So expedites were limited to 5% of total volume, but they were also reinforced that as soon as we have something that the customer has elevated that is urgent, we work it immediately. In order to enable the rules, 3 rules we just mentioned, we did have to make some policy changes, and the first one would be changes in measurements. So the organizational key performance indicator really was changed from how long did we take to do it in the past and how long have we taken to do it this time, to did we meet the date for that purchase request so that we increase the reliability of the overall system. And managers' measurements were changed to things that tie directly to their behavior of following the priority, controlling the WIP, and not letting things get stuck. So the measures were tied directly to the behavior that we were asking of them, not the outcomes. And additionally, we did a reduction in planned award lead times to reflect the increase in speed so that PRs are not getting generated from the system earlier than they're actually needed.